All right, now let's move on to y-intercept. Y-intercept should be pretty familiar to you. The y-intercept is where the graph of your function crosses the y-axis. So I'm writing in where the graph of your function crosses the y-axis. In this parabola or quadratic function here, I know it's opening downward, so I assume that the a value was negative. I think my vertex is probably right about there, but I'm looking for my y-intercept. Where does my graph cross the y-axis? Well, here's the y-axis. If you're following your u, it crosses right here. At the y-intercept, our x value is 0, and our y value is -2. All right, on the back of your paper, let's talk about axis of symmetry. So, think about the word axis. We know this is our x-axis, and our y-axis is vertical. So an axis is like a straight line. An axis of symmetry is a vertical line through the vertex. A vertical line through the vertex that marks where the graph is symmetrical. Okay, make sure you have this in your notes. A vertical line through the vertex that marks where the graph is symmetrical. So if I were to fold my parabola in half, there is a vertical line somewhere going through the vertex, which is, if you remember, the point where our graph changes direction, either the bottom or the minimum value or the maximum value, depending on the direction of your u. So this vertical line goes through the vertex, and if you folded your graph in half, it would perfectly line up. It is symmetrical around that line. So, how to find it? Find vertex. Where is our vertex here? I'm seeing a vertex right here. That's where our graph seems to change direction. It was going down, and now it's going back up again. So this vertex seems to be at, oh, it's the same one as before. This vertex is at 3, x equals 3, y equals -1. So I find my vertex. Then your axis of symmetry is the x value of the vertex. Axis of symmetry is x value of vertex. So my x value of my vertex is 3. At x equals 3, for this example, when x equals 3, that is a line in itself. That is a vertical line that goes through here, right? Any point where x equals 3 is on my line. I'm drawing it in dash so you kind of get the idea. But any point where x equals 3 is on my line of my axis of symmetry. So the axis of symmetry, when you're asked for it, literally looks like x equals, and then whatever your x value of the vertex is. So for this one, the axis of symmetry is x equals 3. All right. One of the most important pieces of a quadratic function is the x-intercepts. So in linear functions, we acknowledged that the lines could cross the x-axis, but it didn't come up that much. In quadratic functions, we will talk about the x-intercepts all the time. The definition of an x-intercept is where the graph of your function crosses the x-axis. So, where the graph of your function crosses the x-axis. An important thing to note about the x-intercepts of a parabola is that it could cross one point if you had a u that looked like this. Here we have two x-intercepts, and maybe if you had a u way up here, you would have 0 x-intercepts. So I'm going to say either 1, 2, or 0 per quadratic function. I use some shorthand here, so either 1, 2, or 0 per quadratic function. There are other ways to refer to an x-intercept. One name is the root of a function. So your x-intercepts are your roots. They are your solutions. If you solve an x or a quadratic function, the solutions are the x-intercepts. Another word for them are zeros, which makes sense because this is where y equals 0. So I see two x-intercepts in this parabola. If I trace it, here my graph crosses the x-axis, and then back over, this is my vertex. Here my graph crosses the x-axis, and then it goes on forever. I assume it won't change direction. We know that these are our x-intercepts. So this graph has two solutions, or two roots, or two zeros, or two x-intercepts. They all mean the same thing. Our first one right here is at the point x is 2, y is 0. Our second one over here is at the point x is 4, y is 0. So in this problem, our x-intercepts are 2 and 4.